Unit 7, radicals. We're going to get into radicals now. A little radical. I might go through this. I don't know if I'll stop in between worksheets, or I might, if I'm going, I might just keep going. So just keep an eye on things as you go. So first thing about radicals is you're going to need to reduce them. You really need to memorize a lot of the perfect squares. So we know, whoops. Hold on. Just did another one on my iPad, so I think I'm going to do that. Anyway. So we know like 1 squared equals 1, so that means the square root of 1 equals 1. We know 2 squared equals 4, so the square root of 4 equals 2. You really need to know all of this. I would say up to, gosh, I don't know. At least 20, in my opinion. So this goes on and on. I would take the time to write those out if you don't know them off the top of your head. But you're not going to know them all. Like this first one, the square root of 1764. I just did it in my calculator. It's 42. But what you might end up doing is saying, okay, let me find smaller square roots and then multiply them together at the end. Or you might check in your calculator like I just did. But what we're looking for when we reduce though is we're looking for perfect squares that are inside of it, and we'll do that in a bunch of this chapter. Another one you might want to know is some of the cubes. We're going to do cubes as well. We talked about it in the last video, but this is going to be 6. Elbow down the wrong place. So this is going to be 6 times 6. Really, you can write it like this. This is 6 times 6 times 6. That's 216. So the cube root is 216. Now, if we have odd roots, I'm just trying to give you something to do. If we have odd roots, we can have negatives. Okay, so that's going to work out. So you can say, okay, this is like saying 32. Let's see. 2 times 2 times 2 is 2 times 2 times 2 times 2 is 16. And another number is 32. So the answer is 2, but there's a negative here, and it's an odd root. So actually the answer is negative 2. It's like we got 5 negative 2s. So we can do that. We can do 5 negative. We're going to say it's 5 negative 1s and 5 2s. That works out the same way. Now this one's no good. I don't know why I wrote this twice. I meant to do this twice. This one is going to give us an imaginary number. We'll deal with imaginary numbers later on if you're going to end up doing chapter 9. But for right now, I just want to say no. Okay, it didn't work out. It's an imaginary number. I know most of you know how to deal with that. I don't know why I did this in problem twice. That's the way that goes. This one is obviously a variable, not a number. We can do this the same way. We can think of this as, hey, we can think about this as the index a little bit. We can rewrite this to say this is a square root. So this is really x to the 2 over 2, which is just x. The square root of x is just x. Same thing down here. We can say, okay, this is x to the 20th divided by 4 because it's a 4th root. So really 1/4 times 20. So this is x to the 5th. All right, 20 divided by 4 is 5. All right, so this is some of the ones that we kind of start out with. Next, we're going to talk about graphing these guys. So we want to graph, and we want to talk about their domain and their range. So let's do the first one. So the first one says square root of x minus 3. So if you have a square root, let's just do this one first. This is the one I want to do first. This is going to be just, let's see, 4, 9, 3. So this right here is just y equals the square root of x. Okay, so what that means is it's just we put in, I put in 0, I put in 1, I put in 4, I put in 9, that's what I kicked out. So they're all going to kind of look like that. But what happens when I put in 3, 9, I can put in numbers. But when I put in this x minus 3 as the next one, what's going to happen is it's just going to shift left or right if I do a plus or minus inside there. So if it's kind of the opposite, what will happen is it will go here, here. It's going to do the same thing. Then it's going to be kind of doing like this. It just shift it over. So this is y equals the square root of x minus 3. It shifts to the positive, does the opposite, just like it does in the quadratic. We'll talk about that when we're graphing quadratic. What about the next one? No, I've got an x plus 3 minus 2. So what that's going to do is it's going to go to the left. So starting like the black y square root of x, it's going to go left 3 and then down 2. This number on the outside here is the vertical shift. So it's going to shift down 2. All right, so goes down 2, so it's going to do kind of the same thing. I'm just going to do a couple just to get it going, and it's going to go forever that way. All right. And how about the cube root? I got the cube root of x plus 5. I can make it plus 5 so that I can get it out of the way of the other. But what's going to happen with that? So the plus 5 just goes up. You know, I didn't label that. I'm going to go back and label that. So this one was y equals the square root of x plus 3 minus 2. Okay. So now for this one, we're going to go up to 5. It's going to start there. The cube root is going to kind of do something similar, except of course with cube root. So you need something like an 8 is really the first cube root that we're going to do with 1 and 8, right? Oops. So 1 would be here, 8 would be here up to. But then, because it's an odd root, it can kind of go this way. It can go in both directions. So it's going to kind of look like a radical, on top of a radical. It's going to do something like that. I didn't draw that particularly well, to be honest with you, but it's because I'm kind of bad at drawing. All right. So let's talk about domains and range. So let's just talk about square root of. Let's do this with y equals square root of x. Well, the domain looks like domain 0 is a valid number, so the domain can start at 0 and it will go to infinity. Same thing for the range. It starts at 0 on the y and it will go up to infinity as well. All right. So let's look at the other ones. For the red one. All right. All this did was shift left and right. So it's actually, for the domain, I can only put in from 3 to infinity. And then for the range, I didn't shift at all, so that's going to not change at all. It's going to go from 0 to infinity. It starts at 0 and it will work its way up forever. It doesn't look like it. It does look like it's going this way, but it's going. It's going up and up and up and up. It's just going a lot slower or something like y equals x or y equals x squared or something like that. But it's headed that way. All right, same thing for blue. Same thing for this one. We're down here is where we're starting. So it looks like our domain is from -3 to infinity. Our range is going to go, looks like we're all the way down to -2. So from -2 to infinity heading up. And we can do other shifts, we can stretch this, we can reflect like it, but we're not going to do that right away. And then the other one is everything. The last one, the green one, the cube root, it is going to go from -infinity to infinity. The range is going to do the same. There's no range, there's no domain that is a problem, and it's going to go up forever, down forever, because it's not. All right, so that's just some of the ones that you might have to draw out for your homework. And that's really all that we had for worksheet 1. So let's go ahead and get into worksheet 2. So it's kind of saying and find the numbers and all that kind of stuff. So we're going to talk a lot more about indexing. Be right back. Sorry, I can use the last time I want to be able to see. So we want to talk about this little part right here. If I have an index on the root on the outside and a power on the inside, I can write it like that as a fractional exponent rather than as a just a root. And that makes it a little bit easier. I think sometimes if we start doing some of the operations, it's easier to work with, easier to think through, and get your answers that way. Especially when we start using our exponent power, our exponent rules, we can apply those. Hey, I can see. All right. So, for example, if we wanted to reduce this one, I got 16 to the 5 fourths. Well, I can obviously put this in my calculator. But what this is going to be is this is like saying it's the fourth root of 16 to the fifth power. Well, I know that's going to be the fourth root of 16 is 2 to the fifth power. So my answer is 32. Okay. That's it. I mean, you can kind of rearrange that a couple other ways, but I find that to be the easiest. All right. Now, how about this one? I've got a negative root, I got a negative number on the inside, negative base. What I'm going to do with this one is, you know what? I'm going to flip it. When I got that negative, now you can do this a couple ways, but you know what? The negative 1/8 can become negative 8 to the to the 5/3. Now I take the cube root of negative 8 to the fifth power. So that's going to be negative 2 to the fifth power. And now I have negative 30. Okay. So you got to kind of think these through, work it through whichever way you want, whether the radical or the exponent. Let's see. Also, we have to be able to, add and subtract these. Now, I think we want our answer in a radical here. But remember all our exponent rules. Let's do this guy. So I've got 2/3 plus 1/2 plus 3/4 on the top. That is going to be what? 12. So that's going to be k to the h12, k to the negative 6 12, k to the 9 12, all over. I got the 2's just going to stay up front. This looks like k to the negative 1/2, right? 2 times 1/4 is 1/2. So it looks like up here I've got k to the 8 minus 6 is 2 plus 9 is 11 12. 17 minus 6 is 11 all over. Hey, that 2 didn't go away. K to the, you know what? I'm going to go negative 6 12. So that is going to be k now with the quotient rule. K 11 minus negative 6 so plus negative 6 is going to be 17 12 over 2. I guess that's what we need. You could also turn back and write that as another way to write this would be 1/2 k to the 12th root to the 17th power. All right, let's keep plugging. Same thing here. It's kind of very similar to the 1/8 one, but this is going to be negative 8 to the 3rd root, and then you're going to square it. So that's going to be negative 2 squared, which is going to be 4. You got to get to know those roots or the square and the cubes. It's the way it is. And I think I have to get this one on there just to kind of remind us, same base. I add together those. So that's going to be 7 to the 6/3 or 7 squared. But remember, add exponents when we're multiplying. All right, add the exponents. All right, okay, let's keep going. More playing with numbers. So remember, this is a square root, right? So this is going to be the base 3 to the 1/2 power to the 18th root. So really 3 to the 18 over 2, or really 3 to the 9. I do not want you to put your calculator in your calculator and type out 3 to the 9. It's a large number. I don't know. That's not worth our time. All right, same thing for this one. I like this one. This is, okay, so M, this is a 2 right here, right? So this is M to the 1/2 power. All the intake to the 1/3 power. Power rule of exponents. This is M to the 1/6. Okay? Same thing for the next one. I got Y to the 1/5. Y to the 1/3 equals Y to 1/15. It didn't say that, I'm sorry, it's saying that in a radical form. I'm sorry, I didn't do that in the first one. So this should be the 6th root of M. This should be the 15th root of 1. All right. Let's keep going. This is going to be M to the 5/3 index times M to the 8/3. I add them together. It looks like M to the 13/3. So that is an M cube root of M to the 13th power. Right. If those two indexes are the same, you can add them together, but I kind of want to give it a process. All right. This one I like. 14, 4th root of 16, y to the 5/4. So this is going to be, think about it like this way. So this is going to be 2, and we could do this. We could say this is going to be y to the, I'm trying to think the best way to show this. You could show it like, let's do it this way. You could do the 4th root of y to the 4th times the 4th root of y. So together those are like a 5th. So this is going to be 2y, and we are left over with 1/4 root of y. Or you could have said, made it 5/4 and then just said 1 and 1/5. It's exponent. Sorry, either one of those is going to work. Here we go, different exponents. But still, all the exponents work. X to the 2/3 over y to the 1/4. So that means this is going to be x to the 2/3 minus 1/4. I think we're back 12 again. That's going to be x to the 4/12 minus 3/12. Looks like x to the 12, or oops. Jeez, that was terrible. Hold on. 12 root of x. I always said drawing is not nice. Good. All right, so I mean, hopefully this is all gone back to you. I'm not doing everything we could do, but hopefully that for those first 2 days went pretty well. All right, let's do some more simplifying, maybe multiplying a little bit. We're all the way up to worksheet 3. Feel free to stop each worksheet and go ahead and work. All right, so these two, we're going to talk about multiplying. You multiply the outside and the inside. So we're going to multiply these two together. The inside in this case is 6 times 11. So this is going to be square root of 66. There's no perfect squares left in there. That's all you can do. We can reduce this. We know there's a square root of 25 in there. So the way I would write this is going to be negative. Keep the negative out front. I would say that's the square root of 25 times the square root of 5. So to me, that's negative 5 root 5. Find the largest perfect square that you can pull out of there. And that way, then you're good. All right? Then take that square root. All right, we always have to reduce. Okay, so this one's going to be, you can separate the two, y cubed over square root of 144. No radicals in the denominators. That's a rule. So square root of 144 is 12. Well, that's care of it. Cube root. Well, that means I can take one of those out, and I'm left with one on the inside. I got 3 of them. 2 of them came out. One was left on the inside. All right. All right. Different bases, but we've got the same index. Okay, so that is going to be, they're different bases, so I think we can still multiply. So this is going to be the 4th root of 21. There's no 4th root of anything that's going to go in there. So 1 is 1, 2 is 16. So that's it. We can't reduce that at all. All right, let's reduce this guy. So when we look at this, we've got a cube root. So the P is going to give us 1, Q is going to give us 2. So first of all, what's the cube root of 64? Well, what goes into 64? I know 8 goes in there, right? So 8. So it looks like, and it looks like 8 can go in there twice. So that means 4. So how about 64? The cube root of 64 is 4. So we can say, okay, cube root of 64, cube root of p to the 4th, cube root of q to the 6th. So this is going to be 4. We'll get one p out of there. That means we have to leave one of the p's on the inside. We got q to the 6th. So that's going to give me 2. And that's it. We're done. All right. This is a fun one. All right. I like this one though. All right. So if I wrote this one, I can say, okay, this is 2 to the 4th thirds. This one down here, we said 2 to the 4th was 16, right? So this is going to be 2, 4th root of 2. So that's going to be 2 to the 4 thirds over 2 times 2 to the 1 fourth. So what we can do is now use the quotient rule. We can put them together first. This is 1, right? So now that's going to be 2 to the 4 thirds, 2 to the 5 fourths. Quotient rule now, 4 thirds minus 5 fourths, 12ths again, so that's going to be 2 to the 16 12ths minus 15 12ths, which means 2 to the 12th, or the 12th over 2 again. Okay? I like that, because with all 2s, it was all basically the same basis. It's kind of a fun one to do. Fun one in my mind. Maybe not yours. All right, let's find the distance between 2 points. We need a radius for this. And you need the distance formula. If you remember the distance formula, it was one of the x's minus the other. So change in x, square that, plus the other, the y, the change in y squared, given the square root. It's not the same as slope. We don't care about which one's x1 and which one's y1. It's just not that important. It's because we're going to square it anyway. So we're going to apply that formula over here. So we got a 2 and a 7 and a 1 and a negative 4 and a 1. So how about we go 2 minus -1. We're going to square that, plus 7 minus -4. We're going to square that, and the square root, that's going to be what our distance equals. It looks like 3 squared, so it's going to be 9, plus 11, which is 121. And we're going to take the square root of that. Looks like the square root of 130. I am not seeing any perfect squares there. Looks like 13 times 10, so 2 times 5 times 13. That's our final answer right there. So that's the distance between those 2 points. You always want, I know you're going to do that, and just give me a decimal. I don't want that decimal. I do want the radical answer for that. All right. That's worksheet 3. This radical chapter goes a little bit slower, but it's still that's radical 3. That's worksheet 3. All right, now we're going to add and subtract these radicals. The only way you can add radicals is if they have the same index and the same index and the same base. Okay, that's the only way. So you might have to do a little work first. Well, here we go. I've got this is going to be 2. There's a 4 in there, so that's going to be. Let me do the whole thing. Square root of 4, square root of 2, minus 3. Perfect square in 50 is square root of 25, square root of 2. So that's going to be 2 times 2, square root of 2, minus 3 times 5, square root of 2, or 4, square root of 2, minus 15, square root of 2, equals -11, square root of 2. All right. You got to reduce those down so you can get to where you want to go. Let's do another. All right, I got 27. So the perfect square, I got a negative. The perfect square of 27 is 9 square root of 3y plus 2, again, the square root of 25. And that'll be 3y. So that looks like -3 square root of 3y plus 10, 5 times 2, square root of 3y. Add them together, that's 7 root 3y. All right. But that initial reducing is very important that you get that correct. All right, cube roots. Ooh, what's the cube root that goes over there? Let's see, 54, let's see. 27 is cube root, right? So 3 cube root of 27, cube root of 2, right? 2 times 27 is 54. So that's a pretty good one. Next one, cube root of, let's say 8, cube root of 2. I might write out all my cube roots too. And there's a 5 out front. So this one's going to be 3 times 3, cube root of 2, plus 5 times 3, cube root of 2. So it looks like 9 cube roots of 2, plus 15 cube roots of 2. Looks like 24 cube roots of 2. Okay. So I would, if I was doing my homework, I'd have a whole list of all the square root of 1 equals 2, 3, 4, 5, all the way up to 20. Cube roots, I'd probably go all the way up to about 7, 8 maybe. Fourth roots, I'd go about 4. Fifth roots, I'd go about 2. All right, let's just keep going. Very similar though, very similar. What's the perfect square that goes over 80? Is it only 4? 16. 16 times 5, right? All right, so 8 times the square root of 16, square root of 5, minus 3. Let's see, 45, so that's going to be the square root of 9, square root of 5. So that's going to be 8 times 4, square root of 5, minus 3 times 3, root 5, 32 root 5, minus 9 root 5. that's going to be 23 root 5. All right. Next one. Square roots again. All right, so I got 2. What's the perfect square root of 54? I think it's 9. So square root of 9. M. I got 3 M's. 2 of them I can bring. So I can bring 1. 2 of them make them square. Square root of that I can bring. What's left over? 6 M plus 5. What's the perfect square root of 96? 36 times 3. No. Let's see, 96. What is that? 96 divided by 2. It's 16, isn't it? 2, 4. Is it 16? Yeah. Square root of 16 M. Because I guess I can square. And then square root of 6. And that adds 8. So this is going to be 2 times 3 M. Square root of 6 M. Plus 5 times 4 M. Square root of 6 M. So this is going to be 6 M. Square root of 6 M. Plus 20 M. Square root of 6 M. Everything matches. So I got 26 M. Square root of 6 M. Not 26 M square root. We're multiplying them. We are adding. All right. We get one this big. Probably. All right. So the fourth root. So I know 16 goes there. So negative 6. Fourth root of 16. Fourth root of 2. See, what is it? 5, 12. I didn't write mine up. So plus, we're going to say the fourth root. Yeah, I guess we divide by 16 again. It's going to be 32, but then you do it twice. So it's 16. So that's going to be the fourth root of 256. Fourth root of 2. All right, so 256. So this would be negative 6 times 2. Fourth root of 2. My handwriting got bad there. Sorry. And this will be 4. Fourth root of 2. So that's 12. Negative 12. Fourth root of 2 plus 4. Fourth root of 2. And that looks like negative 8. Fourth root of 2. All right. Those are the fun ones to play with. When you're doing these in class, just kind of stick with it, I guess. Come ask questions. You can be the one a day. All right. We're up to, I'm just going to keep going. I'm just going to put this all in one big video. So now we're going to multiply. We're going to have, kind of like some of the stuff we did with polynomials, but these are all going to be numbers. FOIL, it's the same thing. It's the same thing, it's just no variables in there. So root 3 times root 3 is 3 minus 2 root 3 plus root 3 minus 2. Combine what you can, so that's going to be 1 minus 1 root 3. Okay? Doing the same thing. All right. This one, we can use the pattern if we want. It's going to be root 13 squared minus 2 times root 13 times root 2 plus, always positive, the square root of 2 squared. So this is going to be 13 minus 2 root 26 plus 2, or 15 minus 2 root 26. Or you could have written it out, root 13 minus root 2, root 13 minus root 2. You could have done that as well. I hope you use that. I hope you use that. It's much more efficient. Get you there a lot quicker. Especially if you're taking the SAT or the ACT and you need to save some time. It's a good thing to do. All right. Oh, I love conjugates. So I know I only have to do these two and these two, put a minus sign in between. Square root of 5 times square root of 5 is 5, minus 4 times 4 is 16, negative 11. I'm done. If you have to FOIL it, you know you're going to see the two middle terms get chopped. 4 square root of 5 and negative 4 square root of 5. You know they're going to cancel each other. All right. Now we have to remember how to rationalize. Now we had one before. We didn't have to worry about it because it was square root of 124. We ended up with an integer denominator is 12, and we were fine. This one, not so much. So the reason we do this, by the way, is because computers used to not be able to handle this. So mathematicians had to do it ahead of time. Now they can. So quite honestly, when you get to college, your professors might not care if you rationalize. You're in high school, we still care. So what we have to do to rationalize is get that denominator out of, or that radical out of the denominator. So what we do is we multiply by the square root of 2. So that means square root of 2 times square root of 2 is 2. But if we do it to the denominator, we have to do it to the numerator. We end up with negative 6 root 6 all over 2. 2 goes into negative 6. So that's going to be negative 3 root 6. So just keep reducing as much as you can. Rationalizing is kind of a form of reducing. All right. Let's move to the next one. Same thing. I do not have to multiply by 2 root 6. I just have to multiply by root 6. So I end up with 5 root 66. Didn't mean to say that. 2 times 6, which is 5 root 66 over 12. And I think that's it. We're done. Because the 5 and 12 will reduce each other. All right. Let's do this one. Now that's going to be a little trickier. If we multiply by root 2, we're still going to have like root 14 in there. By 7. It's not going to get rid of itself. What you have to multiply by, and if we were in class doing this like the lecture, I'd have a long discovery thing. But what we need to do is we need to multiply by the conjugate. This is another use of that difference in squares pattern in that conjugate stuff. So the numerator is going to be root 2 minus root 7. Multiply that by 1. The denominator is just going to be 2 minus 7. When you get that out of there. So that's going to be root 2 minus root 7 all over negative 5. I guess I literally stop there. But you're really not supposed to have negatives in the denominator. So I would say, how about root 7 minus root 2 over 5? I just took that negative out, distributed through it, and switch those two signs around. Or two terms around. But you got to use the conjugate. You got to use the conjugate. That's going to happen a lot. All right, let's just keep working through examples and see what we can do. We can have variables. So we took the square root of y here. Multiply by the square root, right? We'll still end up with 3 square root of 7 yp all over y. Now here's where professors are starting to not care. Because which one of these is better? Is it really better to get that out of there? I guess that's a matter of opinion. But I still do it. Cube root, we got 9 25th cube root of that. Here's how I would attack this one. The way I look at this is the cube root of 9 over the cube root of 25. Well, not 25. Think of that as 5 squared, right? So that's going to be, I guess, you could say that's 3 squared too. So you could say this is 3 to the 2/3, and this is going to be 5 to the 2/3. So what you have to do is you have to multiply by 5 to the 1/3. 5 to the 1/3. Okay? So there on the bottom, if you add those together, that's going to be 5 to the 5 to the first power. It's going to be 5. Think about this. It's going to be, let's go back to, I guess we can go on that. We didn't really do that at the top. So cube root of 9, cube root of 5. So we end up with cube root of 45 all over 5. Yeah. I like still that we did that in the numerator because we're checking. But, yeah, that's enough to worry about. So we rationalize. All right. You know what? Here's one more. One more that we can use our conjugates. So I end up with negative 5 root 6 plus root 3 all over 6 minus 3, which is 3. That's it. I would stop right there. I don't even think you need to distribute that negative 5 through. You can leave that factor out of that. All right. Those will help you with worksheet 5. All right, here comes fun. This is what we do now. We learn some skills, and then we apply it to an equation. So, not a surprise. The last thing we're going to do here is equations. This will also lead us to the quadratic chapter, which that's all we're going to do is solve them there. We have a lot of skills throughout the summer. That's what this will lead us to some skills here. So what if we have a radical in the equation? All right. So basically, it's opposite operations. Just like plus and minus are opposite, and divide and multiply are opposite. Square root, the opposite of square root is square. So if I square that side, it kind of peels off that root and end up with this. So I have to square this side. 25. So now it's just 8x equals, and we'll subtract 9 from both sides. Looks like 16. All right, divide by 8, x equals 2. Check your answer. You gotta check your answers. Even just you do a mental check because when we do quadratics and when we do radicals, just goofy things happen. Sometimes it just doesn't work when there isn't an answer. If I look up here, that's 8 times 16 plus 9 is 25 squared. Okay, it wouldn't work. Okay. And just call that a fair warning. All right. I'm going to square both sides on this one. Careful. When I square both sides, I got to square that as well. So on this side, I'm going to have 10m minus 9. Over here, I'm going to have 9m. Think of that as 2 parts. So that just gives me, bring the 9 down, I'm giving you m. That over. So looks like m equals 9 for this one. And again, plug that in. That would be 3 times 3 is 9 on the left. That's going to be 90 minus 9 is 81 squared. All right. So be careful when you square. Here's the part right here. Make sure you're squaring the entire side. You're not just squaring the square root. You're squaring the entire side. All right. Fourth root does the same thing. Here's a fourth. X plus 6 equals 2x. Looks like 6 equals x. So that looks like 12. So 4th root 12. It works. All right. Just peel off. And that one's kind of makes sense too, because this part underneath you got the that. So they are the same. All right. here's where I want you to check. All right, so if I square this side, and I square all of this side, this is going to be 3m plus 1 equals 1. Well, that means 3m equals 0, m equals 0. We'll plug that in. 3 times 0 is 0, plus 1 is 1. The square root of 1 is not negative 1, right? And hopefully you saw that very beginning, and you saw the root. I mean, I can't take a square root and get a negative answer. It's almost like an absolute value in that sense. I can't take a square root and get a negative 1 without imaginary numbers or coupled numbers, something like that. So that one doesn't work. So this one is you would say no solution. M does not have a solution that makes sense. There's no square root that's going to give me a negative. If you notice that right away, fine with me. Fine with me. If you want to say you're done, you're done. All right. This side, again, square root or square everything. Get P out of this, square this side. I get P squared plus 3P plus 7. On this side, I square this, and I get, P squared plus 4P plus 4, right? That's our way of handling that. All right. Looks like the P squared are going to cancel each other out. Looks like I get P equals 3. That's one I made a check. On the right, it's got a 5. It's 3 plus 2 is 5. Okay. On the left, 9 plus, looks like another 9. So that's 18. 18 plus 7 is 25. Square root of that is also 5. So that one works. Good. That one works. You don't have to write down your check. You can use it mentally. That's fine. All right, and the last one of this chapter, and this is the fun one. So we had one with the radical on both sides a couple times up here, but they were just a radical by itself. What happens when we have a radical and we have a given? So what you want to do is you want to get a radical on the inside. So I'm going to rewrite this as x plus 2 square root of x plus 2 equals, let me do this way, x minus 3 plus 1. Now it's time to square both sides. I'll square this side, and I'll square all of this side. So now this is x plus 2. This becomes, you got to use that same pattern. So square root of x, square root of x minus 3, square root of x minus 3. That's going to be x minus 3 plus 2 square root of x minus 3 plus 1 times 1, which is 1. Let's clean that up a little bit. That's going to be x plus 2 equals x minus 2 plus 2 square root of x minus 3. All right, so the x's look like they cancel. Then add 2 to both sides. That's going to be 4 equals 2 square root of x minus 3. Divide both sides by 2. 2 equals square root of x minus 3. I'm going to square this one. I'm going to square this one. 4 equals x minus 3. Looks like x equals 7. Let's see if that works. All right. So if I put 7 into there, this one I might jot some down. So that's going to be 3 square root of 9. 3 minus square root of 4, which is 2, equals 1. Yep, that works. All right, but the key is to get one of them. I guess you could do it on the other one. It gets really hairy. It gets really crazy. I like putting one on the other side. Plus, I got rid of the negative. The negative gets a little goofy. So yeah. So that's chapter 7. I really hope you ask more questions on chapter 7 because it's a lot of work, and I hope you can need help come and get it. All right. Have at it.